Good.
30, across from 30 is 1, across from 90 is 2, and 60 square root of 30.
Okay.
Oh, hell yeah.
Perfect. Wait to remember this. John, you have a different one? Oh, you want to do this one?
Yeah.
Okay, hold on 1 second on that one. Did anybody do the 30, 60, 90 differently? Everybody's okay with that?
Yep.
Okay, John?
Across from 90, you do square root of 2, and then across from 45, you do 1 for both of them.
Okay, good. Everybody okay with that? Okay. Anybody do something different? They're all similar triangles. Guys. And similar triangles, what do you know about similar triangles?
Two angles, one angle is the same.
The angles are the same.
It's just the size.
What about the sides? They're different, but what?
Corresponding, or they're like dissimilar in ratio.
Ah, they're in proportion. They have a ratio. They're in proportion. Okay, the sides are in proportion. So if I label this side 4, take a minute and find the sides that correspond to those angles. You told me similar triangles have the same angles, right?
Oh,
but the sides are in proportion. They make a ratio. So how would I label those other sides? Okay, so just double. From here to here, we doubled it. So we multiplied by 2. So from here to here, you multiplied by 2. You multiplied by 2. Right? Okay. If I did this, what would my hypotenuse be? 6, because this I multiplied by 3. This would be 6. What would this be? 3 radical 3. Good. Okay. 45, 45. If I make this a 3, what would my sides be? 3 and 3 radical 2. Okay. If I made this a 2,
2, 1, 1.
You're right, it'd be 2, 2, and no.
It'd be
It'd be 2,
1 and 1
2, 2.
still.
but how could it be the same as this?
Because you squared it.
But then if I did 1, 1, if I put a 1, 1 here, this would give me 1 squared is 1 plus 1 squared is 1. That would give me 2 squared is 4.
No, but you squared the square root of 2.
You squared it.
You squared the square root.
By what though? If I squared the square root, what did I square it by? What did I multiply it by? I multiplied it by itself. Ah.
So it would be radical 2, radical 2.
Radical 2, radical 2.
Do you see what I meant? I was squaring the 1.
I see what you were doing. You were doing the same process.
Yeah.
But you have to make a ratio.
This is
And,
silly mistake.
and I so get that. That's why I always like to throw one in with the radical here because it looks a little different. Okay, now, the last one we're going to do is this one. Let me label again. I want my, excuse me, I want my hypotenuse to be 1. So 1/2 is off the 30. Radical 3 over 2 is off the 60. Good. Okay, what about these guys? Divide by radical 2. Very good. If I want radical 2, if this is radical 2 and I want to get a 1, I'm going to divide it by a radical 2 to get me 1. Good. That means I have to divide 1 by radical 2 and 1 by radical 2.
We don't have to rationalize.
You don't have to rationalize. In precalc, we don't rationalize. Yes, which in the beginning when you start trig is going to be a little different because when you do sine and cosine of 45, you automatically say radical 2 over 2.
Oh.
So you can leave it 1 over radical 2. If you give it to me radical 2 over 2, it is not wrong. Now, from these guys, we can start your unit circle. why could I use these triangles on a unit circle?
Unit circle, the radius is 1.
Good, very good. Because the unit circle, the radius is 1. So we're going to start here. We're going to talk about your unit circle for a minute, and we're going to come back to that. I just wanted to do like a pre-thing so that you guys would remember your 30, 60, 90, and your 45, 45. And that really is like the basis for trig. Without knowing those triangles, it's difficult. And do I need you to memorize the unit circle one? No, you can always convert it from unit circle one. Whichever one you memorize, you all memorize the same way that I do. It's the easiest way to do it. And then we can convert them to whatever radius we have, whatever side we have, any of those things that we need to get to. So taking a look at your unit circle, we say that it is a unit circle because the radius is 1. So it moves 1 out here, 1 up, 1 over, 1 down. Now, in pre-calc, we mostly work in radians. And we do the same thing you did, xy, cosine sine, xy, cosine sine. So if we're looking for the sine of 0, or 2 pi, doesn't matter which one we look at. If we're looking for the sine is its y value. So the sine of 0 is 0. It's its y value. What is the cosine of 0? It's its x value, 1. So for your quadrant angles, we call them quadrantal angles. For your quadrant angles, all you need to do is xy, cosine, sine. It's in alphabetical order without picking up your calculator. So I say at 180 or pi, xy, cosine, sine, what is the cosine of pi? -1. What is the sine of pi? 0. Okay. What is the sine of 3 pi over 2? -1. What is the cosine of 3 pi over 2? 0. And you have a pattern for this. The most important part to remember is this. 0 and pi. 180 is equal to pi. So if I'm doing 90, isn't 90 half of 180? So how do I write 90 in radians? Pi over 2. I take half of pi. And 270 is 1.5 times 90. So if I did 1.5 pi, it's the same as 3 pi over 2. So I'm going to run this around my circle in radians. We're going to work radians as well. And I want you to get used to using x, y, and r. Don't give me opposite over adjacent, adjacent or opposite over hypotenuse. If we're not working on a circle, then you use that one. If we're on a circle, I want you to use your x, your y. We'll do SOHCAHTOA when we're going to do like basic applications in this unit as well, just to get you remembering them. But when we're ever on a circle, we're x, y, and r. And I find it easier, and if you struggle with doing this, you could set this up. I call this my information box. Every time we drop a triangle, make your information box. Some of you remember, all students take calculus, chemistry. Yeah, Mr. Schaefer, crack. So whatever you remember, that works too. Talk constantly.
I thought we said all surface space.
He says all different kinds of things. He says all different kinds of things.
He does.
But isn't that the one to remember?
Yeah.
So
He did say the all surface takes crack too.
he says all kinds of things. Okay. Alright, so your basic trig functions, guys. Your basic trig functions. It still works the same as you know and love. It still works opposite over hypotenuse because here's my angle. All angles open up here. They open up, this is called standard position. They open up from the positive x-axis and they open counterclockwise. When you label your quadrants, where is quadrant 1?
Top right.
Top right. Where's quadrant 2?
Top left.
So doesn't that make sense? I start in quadrant 1, I go to quadrant 2, I go to quadrant 3, I go to quadrant 4. That's why we label them like that, because that's how your angles rotate around your circle. So you don't really learn the meaning to that. You learn 1, 2, 3, 4 when you're in like 8th grade, 7th grade, but you don't put it together with your angles yet. So what we're doing is we're taking your axis, we're putting your unit circle on it, and we're rotating your angles around. The next part of trig will take those angles and make it a sine curve. We'll strip down your unit circle. So now, the opposite here is your y. Your radius is your hypotenuse. Adjacent is your x. And it's going to happen anytime you do an angle in any of these quadrants. And look what they make. They make a bow tie. So remember that your angles open up and down. Your triangles come down to the x-axis. Not this way. Picture me trying to wear a bow tie if I went on the y-axis. So my angles will never look like this. My triangles will never look like this.
Never.
Never. They will have to make me a bow tie. Okay? Is everybody familiar with these ratios? Okay, so we're going to start memorizing these. Now, if you forget how to do this, an easy way is this. Go to your sine, cosine, tangent. On your triangle, on your unit circle, what is your radius? Which part of your radius is your triangle? The hypotenuse. So we're going to make it an R. So on the opposite side, what side is that?
Oh, opposite, sorry.
Is the Y. So we're going to make all your O's a Y. And your A's, therefore, are the X's, the adjacent. So sine is Y over R. Cosine is X over R. Tangent is Y over X. And another easy way to remember, sine is Y over R.
The what?
What letter am I missing?
She's just spaced out.
Sine, cosine, tangent. And another easy way to remember it is XY in alphabetical order, AO in alphabetical order. Can we focus up here, guys? Come on. Come on. All right. And your reciprocals, everybody remembers your reciprocals?
Yep.
Yes.
Easiest way to do a reciprocal is not this way, it's this way. Flip this over. R over X. I'm sorry, R over Y. R over X. X over Y. Flip these over. Okay. An easy way to remember tangent and cotangent are reciprocals. They start with different letters. So sine cannot start with an S. It has to start with a C. That'll help you remember that it's cosecant. In case you struggle with remembering. All right. So moving right along, we're going to find your values. And you see that chart in the back on the last page? We're going to fill in your chart
For now?
as we do this.
Okay.
You don't need to memorize this. I don't need you to memorize anything. You can take it. You memorize the circle how? The one position, right? All you do is
Memorize
you do.
the function.
Just those. You just have on that chart, you don't have to memorize that chart. Some teachers make you memorize that chart. You don't have to memorize that chart. You just have to know how to get it off to the circle onto your chart.
Yeah, Mr. Schaefer always had us do it so that we were like.
So that you're quick.
I never got that.
You can take it right off your circle. So, we're going to start with the 30-degree triangle, and we're going to label for a unit circle. Alright, so opposite the 30 was what value?
1.
The radius is 1. I'm on a unit circle. So go back to the forms of pages that we just did.
Oh,
Go back to your triangles that we just did. Find the triangle that has a radius, a hypotenuse of 1. 1/2. What's opposite to 60? Radical 3 over 2. We're using the hypotenuse, that's a 1. You memorize this. Watch. This is the one you memorized, right? But I need to put this on. I need to put this on. Oh, come on. You know it's a 30. I need to put this on a circle whose radius is 1. I don't find it funny. Come on. Yes.
So all we have to do is memorize the one plus the one.
All you have to do is memorize the one that you were comfortable with, the one that you gave me to start with.
We're not using that.
You're right. We're just using a similar triangle. So didn't we just go through all the similar triangles? And so the very last one that we did, Jordan, the very last similar triangle that we did, let me bring this back. Where's the last similar triangle that we did? The last similar triangle that we did, and I said, this is what we're going to use on your unit circle. We said the radius has to be 1 on a unit circle. So you still memorize the one you know. All you have to do is make a similar triangle. Okay? Because we're on the unit circle. Right now today we're using a unit circle. And the unit circle says the radius is 1. So I'm going to put this on my unit circle. This is 1/2. Opposite the 30. Here's my 60. Radical 3 over 2. Okay. X is equal to. Y is equal to. R is equal to. If I wanted to find that point on that circle, how would I name that point? I need to know what this, I know this point, right? I know this point is 1, 0. I know this point is 0, 1. What's this point? If I went 30 degrees up, what's this point? No, I just want the value of x and y. Okay. Radical 3 over 2, comma, a half. X and y. Don't you name a point on a circle, x and y? Right? So didn't we say on your unit circle that the cosine is the x part, x and y? I'm going to have to write over that. Cosine sine. Didn't we say that the x is the cosine, the y is the sine? Right? So if I want the cosine of 30 degrees, what would my answer be? Square root of 3 over 2, because it's x over r. My x value is this, my r value is 1, so I technically don't need the r, right? If I say the sine of 30, it's 1/2, because it's really y over r. My r is 1. And my tangent of 30. My tangent says y over x. What's my y value? 1/2 over. To cancel out the 2's, because I'm going to flip it over. And what's my tangent? 1 over square root of 3. I'm on a unit circle. If I wasn't on a unit circle, what if I was on a circle that did this? What if I was on a circle that had a 2? Then you would do this. 1, radical 3. Your cosine of 30 would be x over r. Would be radical 3 over 2. Doesn't it all reduce down to the same thing? They're similar triangles. But on a unit circle, your radius has to be 1. So we're just going to use the triangle that gives me the radius of 1. But no matter what you build this up to, any of those triangles that we did with similar ratios, they will all reduce down to the same trig functions. Now, I can make 4 angles. You told me I can make a bow tie out of this. What transformation do I use to get this triangle into the second quadrant? Good. A reflection over the y-axis. This will build me another triangle, a congruent triangle. There's my 30, there's my 60. My sides are exactly the same. So therefore, should my sine, my cosine, and my tangent be the exact same for this angle? In degrees, what would this angle be? If this is 30 and this is 180, what would this angle be?
Oh,
Good. So shouldn't the sine, the cosine, the tangent be the same as 150?
yes. Yes, it is.
Yes and no. Why no? The sign is positive, which one's negative?
Oh yeah, the sign is positive, everything else is negative.
The sign is positive, everything else
Oh.
is negative. Why? Why does that happen?
Because all strippers can cancel.
Okay, without the strippers. Let's use the axis here. My circle is on an axis.
Oh, because the x value is negative.
Ah, very good.
Sorry.
Because we use our unit circle, but you didn't see it on an axis, right? You just saw it as a circle. So if I put my circle on an xy axis, doesn't this tell me now that my x is negative? But yes, it has the same value as before. X is still going to be,
The numbers are the same, but the signs are different.
but the signs are different. It's just going to be a negative. My y is still in this quadrant, and my r is always positive. Why is my r always positive? You can't have negative distance. Good. A radius is a distance. So your r will always be positive. So yes, this fits into your all strippers pay cash or whatever you like to say.
Sorry, I just thought.
No,
that
this
we
is
were
fine.
recording.
It's just this weird saying it's in my class. So, but the same as my my hippies taking acid here. So okay. So now it's gonna have the same exact things except for whatever uses the x, which is cosine, will be negative, and tangent uses an x, so tangent will be negative. Agree? Now, when I bring it into this quadrant, this says, okay, reflect this over the x-axis. So, okay, this is still opposite the 30 is my 1/2. Opposite the 60 is still my radical 3 over 2. It sits right there. But who's positive and negative now?
Tangent's the only positive.
Tangent's in the positive. Why?
Because the negative x over the negative y would make it a positive.
Good. My x is going to be negative. My x will be a negative.
I didn't bring this.
And my y will be a negative. Good, because I don't want you to think that. I want you to build this on your xy axis.
Thinking like a mathematician.
I want you to see it mathematically. I want you to see why this happens. It happens because in quadrant 2, x is negative, y is positive. In quadrant 3, they're both negative. And when we go to quadrant 4, same values, except for which one now, pretend this is quadrant 4, which one will be negative? Cosine in quadrant 4. But what's my x value? Positive.